from our last conversation,
which
Kirsty,
is awesome.
which was awesome, right?
Mhm.
Um,
Thank you.
it became apparent. I was like, we need to go into these dimensions. Like, we're gonna have to go into each one like in depth. And so that's what I was thinking about like doing today. And so I figured I could feed two birds with one seed, and we can talk
Mhm.
about the fourth dimension of time. And then that way we can read your comments, and that'll be relevant to our discussion. Because hey, length and width and breadth are pretty, excuse me, self-explanatory in terms of Russell's dimensions. I guess the only thing I would add for the people listening later is that Russell says all of the dimensions are they're illusions of motion. Okay, so even when we think of like length, that's an illusion of motion, and I think he said that all the dimensions are relative. So like they change depending on your like where you are and what's going on. Actually, let me I'm just gonna read a little something from his chapter on in the Universal One concerning dimension. He says the elements of matter are all of the same substance in varying states of motion. Gold is not one substance, and carbon another, and phosphorus still another. Gold differs from carbon, and silicon differs from copper only by the relation of their intervals in motion or the measurements of their separate dimensions, which, when aggregated, constitute their separate states of motion. So, it's really that's really something unique to Russell's concept is he's saying like, look, everything in the universe is really just one substance. It's light, and he's calling it light, moving light. So the different things that we see are really the same thing. They're just moving differently. So it's an illusion of motion. And and so he talks about the elements, being that way, but then he goes into, saying that all the dimensions are the same. They're also illusions of motion. Russell's concept of time is another just amazing, like such a creative. I'd never heard this in any other kind of theoretical physics. Um, there's all different kinds of theories, or rather, people kind of trying to create new ways to explain the universe. And I'm telling you, I think Russell is the only person that I've ever heard talks about time in like not that there's just one time for him. Time. Oh, and let me read his definition of time because it's actually pretty awesome. Time, the fourth dimension. He says time is the measure of universal repetitiveness. And so for there are a lot of people out there in theoretical physics, talking about, what is time and this and that, but he's, Russell just I love his it's so simple, and yet it leads to so much complexity. But he's just saying, time is the measurement of universal repetitiveness. All phenomena of nature are repetitive. All repetition is sequential. So time is the interval between the sequences of events. Were there no events, time would not be. If nothing, quote unquote, happened in the universe, there would be no intervals. So intervals of time are illusions which give birth to other illusions known as relations. Without intervals of time, relations would not be. And without relations, dimensions would not be. All dimensions are relative. Okay, so that's and he says time is a dimension. So that time is therefore relative. And one last thing, yeah. Time dimension marks the periodicities of all phenomena of motion. So he's saying time, time belongs essentially to motion, and it's not an attribute of substance.
So when you look at a cycle of life,
Yeah,
we are born, we grow old and die for, let's say, 80 years.
right.
And then for 80 years, we'll be in the center of the stillness before we're born again.
It's funny you say that because the very next thing he said is, in inertia, and for people, when Walter Russell talks about inertia, or like the inertial plane, he's talking about non-movement. Like everything that we see, he says, is light that's in motion. But at a certain point, that light stops its motion, and we call that, death. Um, but or he calls it inertia. So he's saying, in inertia, time, like all other dimensions, does not exist. So I just think that's really interesting. Wow. I would want to just keep reading this, but look, you guys, definitely everyone should get the Universal One. It's an awesome book, read it and it will open your mind to a lot of interesting things. So that's kind of Walter's concept of time. It's definitely related to, it's one of the dimensions, so it's relative, and it's an illusion of motion, as are all of this other 17, of the 18 dimensions. The thing that I really thought was amazing about Walter's concept of time is that he breaks it down into two um he breaks it down into axial rotation and orbital revolution. And those he calls those dimensions in themselves. Like revolution, he says, is the 13th dimension. And rotation is the 12th dimension. So, but those are like, directly related, to time. And we can kind of understand that as like, the Earth orbits the sun, that would be one revolution around the sun, right? Um, and we know that's a year. So it's kind of locked to a time interval that we're familiar with. You take the axial rotation of the Earth, it spins around one time, in about 24 hours. So that's another, time, that we're familiar with. But Walter shows how those two, the axial rotation and orbital revolution are related. Um, and it's dealing with time. So, all of his dimensions are related. But so I think I want to go in and take a look at some of the at the thread that we had, Scott. And so if anyone wants is just watching this, and they can kind of pause the video if they want to read through all of this. But I'm going to go down, since we already had this discussion, and I want to see the new comments. Thank you for sharing your thoughts. As you've read through these chapters, it's helpful to hear other people's thought processes and questions that arise. I thought I would add here that I've just read the Russell Generative Radiative Concept. Oh, great. Yeah, page 53. Great book.
My
Oh,
layout's different. I think it'll be a different page number for you.
oh, yeah, that's right. For that book, we do have different. Okay, okay. So I'm not
Mm.
gonna go searching for it. But oh, you put the quote in here. Okay, let's see. These space
Yeah.
controls between large masses, although invisible, can be located mathematically, and this knowledge will greatly aid the astronomer in retracing the path of our solar system through the ages gone by and its future path. I have already located its present position in its wave as corresponding to that occupied by iron in the elements. It is not, however, a celestial atom of iron as first calculations indicated, for it has not yet reached the octave in its cycle occupied by iron. Okay. It is in the plane of iron, which he means in the when we talked about the formula of the lock potentials, you've got, 1, 2, 3, 4, 4, 3, 2, 1. So he's talking about the plane. That's another dimension. The plane falling
Just
down here.
FYI, I
Yeah.
would love to know what formula he used to figure that out.
Oh, Yes, you and me both. That is something that I was hoping, this group would be like the place to like figure that out because he gives us all this information, right? But so step one is like reading it and taking in all this information and, getting to know it so well that you understand his whole concept. That's
Yeah, but
like,
his second book that he never wrote. I wish we had that.
oh, I know. Oh my gosh. Yeah.
Uh,
Oh, like in the beginning of the Russell generoradiative concept, he talks about different things that he's going to write and the books he's going to write. And I was like, where are these books? I would love to read these things. Like, but alas, he never got around to writing them. So, but I thought this would be a good place to, well, wait, let me finish my thought. It's just once you kind of know his concept, now you have all these tools to be able to figure things out. And so you have to be able to use them to figure things out. Like, you know, like, yes, what formula did he use to like how did he figure out that our solar system is in the plane of iron? And that was the exact same question I asked, to Darren, who's my mentor. I feel like Darren is, probably knows Walter's stuff better than any human on the planet, just because he had special circumstances of being, the chief science officer and having, for years and having access to all of the things that were unpublished and like all of the drafts and things that Walter wrote and like his notebook. That's something that I look forward to sharing with you guys. And, at least as of now, you two are like, I think the people in the group who are the most, kind of studied and are actively, into it. And so I do think that after we kind of go through some certain levels, I definitely have some things that I want to share with you guys that are unreleased to the public from Walter, like some of his direct notes and things and new diagrams and that kind of stuff. Um, but they're more advanced. Um, like there's no point in really like looking at those yet until you kind of get through all this other stuff. But and I also have to make sure I have permission from the University of Science and Philosophy to like release it to you guys, which I think I will be able to get the permission from them. But
and Kirsty, her art skills are great, and the best I can do is stick figures.
oh
Thank
man,
you.
yeah, oh yeah,
I do stick with too.
Oh, and Kirsty, you're fast too. You did those drawings quickly, and you were like, "Oh yeah, that was just a quick drawing." I was like, "Whoa, impressive." Um, okay, so anyway, yes, finding out about how he figured out what plane our solar system is something that is I would like to dive into, and talk about, but that's at another time. So I'm going to go back to reading. Let's see where we left off here in Kirsty's comment. Let's see. Right. Right. It is in the plane of iron, but in the carbon octave between boron and carbon. And one second, bear with me. I want to look at my periodic table really quick. So, right. So iron's in the seventh octave, but he's saying it's in that same plane from 0 to 90, but it's in the fifth octave of the carbon octave rather than the seventh octave. So I think that's a little bit of a hint as to like some of the things he was looking at to kind of figure that out. But okay, so now this is Christie's comment. I presume the book, The General Radiative Concept, may have been written more recently. So this may be the update on our solar system sun's location. Yes.
as far as the date of publication, but I think that our sun would not have moved much, if any, maybe millimeters from the time that the two books were written.
Oh, I mean, it's moved a lot. I mean, it's moved. I mean, it is spiraling around the Milky Way at
Yes, but as
however
far
many,
as
but like
position,
relative, like
yeah,
position, you mean? Right. Oh, you mean like the plane? Right.
yeah,
Right.
yeah.
Let's see.
Because that probably hasn't changed. That probably won't change for, you know, 500 million years or
Yeah,
something.
that's a long like the cycle of the sun, which we all know, the life cycle starts at the inertial plane, it goes up to 90 degrees at maturity, and then it goes back down, where it came
And then
from.
we'll have a black hole there.
So yeah, that cycle is extremely long. Right. Millions and millions of years, right? Um, uh, yeah, how long do suns last? I don't know. I have to look at NASA or something. Okay, let's see. Which I like because if our sun is heading towards a perfect sphere, then carbon would sit better within this concept. And also, our solar system has four inner planets, solid, and four outer planets, gaseous, with an asteroid belt in between, right? Equilibrium turning point.
Yeah.
Um,
And
which,
Kirsty's right because it has to be in the carbon because once it reaches carbon, it is a perfect sphere.
right, right. Yeah. Let's see here. Which might put our the sun at the end of its piston in the middle of the cycle, where the gear wheels are of equal size in the universal machine, right? Mentioned by Walter on page 49 of the same book. I would love to see a diagram of our solar system within the Russell cube sphere wave universal machine concept. Ah, yes. Okay. So, yeah. See, now that is getting into the cubic wave field, which in my opinion is the most advanced, you know, uh, concept of Walter's whole concept. And it's like there's a lot that goes on there. Now, it's funny that you mentioned the four inner planets being rocks or solids, and the four outer ones being gaseous. That was kind of an aha moment to me because in atomic suicide, which is kind of, at least I was told by Darren that he felt that atomic suicide was the best description of Walter's science. Because he does go into it, in depth. And one of the things he says in there is that mass throws off rings, and it's always four rings. And so I looked at like our solar system, and I was like, oh, so then that kind of means the first four rings were the gaseous, or well, that was a set of rings, like the gaseous ones that came out. And then there was another set of four later that came out, which were, the solids. And they will eventually become gaseous because they're expanding away from the sun. And we all know, like, as things expand away, that radiative force is the dominant force there. And the planets literally start to expand, and they go from solids to gaseous. Um, so I just thought that was interesting when I heard him say that rings, that mass throws off rings, set of four rings. And I was like, huh, yeah, our solar system has that four gaseous and four. And then it also makes me think there was probably four more, like way out, like Pluto and, the whatever planets, I guess, are past Neptune. they're they've gotten so expanded. I mean, we don't even see them as planets anymore. But theoretically, I guess that would be another set of four rings that are like way out there, that happened a long time ago. um, So,
Another octave.
right. So this is a good idea in terms of a a diagram that would kind of show um our solar system in the Russell's cube sphere, wave universal machine concept. Trying to think if there's anything. I guess the closest to that would be there's a diagram in the universal one. Well, there's a diagram on page 157 of the universal one. And let's see, it's called the creating universe is a reflection of its concept in inertia. What he shows is kind of like, oh, let's see, I don't know if you guys will be able to see this, but yeah, I'll just kind of try to um it's not really going to be very good.
Is that page 151?
So,
157.
Opposite.
And let me see if I might be able to find let's see, it's in chapter let's see, chapter 13, expressions of gravitation and radiation. And it's about, yeah, 6 pages into that chapter. But he essentially shows let me do a quick let me just do a quick search because I might be able to then just share the screen. This is the diagram. Let's see. Can we get it a little bigger, maybe? View image.
So basically what it looks like to me is that he's showing solar systems at each corner
Here it is. Right. Yes. Okay. So
of the
so
cube.
Kirsty, in terms of your question, like how our solar system would be, in Walter's concept. So, and okay, this is the cubic wave field. You can see this box, this cube in the middle, and it's got, these planes, but let me see. There's one other, hold on, there is one other diagram which will help. Okay, so this one you guys have probably seen this one before. So he's got a cubic wave field over here, and then another cubic wave field over here. And so, like in this, he's kind of showing the spirals, how they would start on this inertial plane, like at the base of the spiral. And as it spirals faster and faster, it gets tighter and tighter, and it winds up to the corner of the cube. And that's where
The sun is.
the sun is. That would be the amplitude of the wave, and so if we keep this in mind, how, it spirals up to the sun. Now, if we look at um, this diagram,
And
it's
I'd
the
also
same.
stipulate that
Yeah.
where the circular cone
Yeah.
is where the black hole is.
Oh, okay. So, yeah, that's and now there's yet even another diagram. He actually draws that. Let me see if I have it quickly here. Um, no, I don't think I have that one downloaded. But but you guys didn't miss much on if you're watching the recording. We just were setting up this whiteboard and loading these pictures in. Now we can start with Kirsty's question. Um, and she wanted to kind of see kind of how like our solar system, how it's kind of placed in um in kind of the Russell's concept. So the way I would describe it, Kirsty, is that, like Scott says, this, what's happening here in this cube, it happens like this everywhere, regardless of the size. Like it could be an atom, it could be, a solar system. But this is just how matter starts its life cycle and grows to maturity as it goes, so let's see. I don't know how this is going to look, but I can just share my screen and actually open up a little paint program
Yeah.
um
Okay.
on my
Yeah.
computer, and that'll be the whiteboard that everyone will be able to see. All right, so here we go. Let's share. You see this black line in the middle, that goes like this. That is what we call, Russell calls it that there's a point in the middle, and around this point, everything is spiraling around. Okay, here we go. So, and I'm going to use a different color just to illustrate. So, this number one position is represented by, there's like, he's got a circle here. Now, the way that Russell talks about it is that along the gravity shaft, actually, which I'm actually going to make yellow, along the gravity shaft at certain points, we will then find spiraling, we will find a rim on a string, or like a um essentially around this gravity shaft at this we will find a circular system,
Mhm.
and that would be like the Milky Way or our solar system. At another point number two, which is blue, there will be another, you know, circular, you know, system around, but it's always confined to our, this is our, I'll use brown here. This is our cone that's leading from the inertial plane headed towards the amplitude of the wave at the 4 plus plus position. And we'll do one more. Let's use pink. At position number 3, there will be, around the gravity shaft. Let me see if 1, 2, 3. Yeah, it would be somewhere like around here, but it'd be smaller. You see, like each system is still confined within the brown, the brown spiral cone. Okay. So, and at position 1, the system that's green, it would be kind of bigger. So, there could be like a solar system there, um, spinning around, or like a Milky Way. It would be a spinning disc. That's the UC word. That's the word he used. A disc. So they're like discs on a string. So the gravity shaft, which I show in yellow, is the string, and along the gravity shaft, there are discs spinning around the gravity shaft. And they appear at these locked potential positions. And so our solar system would be, could be any one of these. It could be the green one, the blue one, the pink one. The only difference between, say, the pink one and the green one is just the pink one is a higher potential system. Everything is spinning faster and tighter, smaller space, less volume. Whereas, the green one would be, a lower potential, because everything would be spread out more. It'd be spinning slower. It'd be more expanded. So, oh, and let's see, one other thing I want to bring up. Where's that picture? Oh man. Oh, I know the picture. I know this is the picture I need. Yep. Okay. You are about to Okay, can you see this picture right here with all these colors? Okay, this is the only place that Walter drew this in a diagram. And I wish he had drawn it more. I'm going to, so this is from his artwork that he, let's see, what is it? Steps in the Construction of Matter. There's like three, I think three or four parts, A, B, C or A, B, C, D. I forgot how many there were. But in this particular drawing that he did, I'm going to bring your attention. I'm going to zoom in down here. Now, what we're going to see here is the same thing that we've always seen, like a spiral. You've got your potential positions of, 1, 2, 3, and 4 at the amplitude. He's drawn the gravity shaft in black right here. And we've got our potential positions. Now you'll notice at +1 right here, he's drawn a line. There is a spiral that is that its apex is right along the 1 line. Now, he also drew, and it's a little harder to see, but you can see there's another spiral in green, and its apex is on the 2 line. Then there's one in blue where its apex is on the number 3 line. Now, even harder to see, but you can probably see it. He's drawn, you see like this line here that meets the red spiral. It's actually this line goes with let's see, where is it? I think it's this one right here. And what he's trying to show is that at the +1 position, there are 2 cones meeting. Um, like this. There are 2 cones. And at the apex where they meet, for example, if we look at the ones that meet at the 4 plus position, this is the one that he always drew. He drew 2 cones meeting at the +4 position. So we know like there's a sun there. And if there's a sun there, then you can imagine around that sun, there's a spiraling disk of a solar system. Okay. And it would be like, up and down the plane of the solar system. In this diagram, which he has never drawn this anywhere else, he shows that actually at each 1, 2, 3, at each potential locked potential position, there are a set of, there's a pair of cones meeting there, just like there's a pair of cones meeting at the 4 position. And so therefore, there are also disks of systems at that apex of those cones where they meet. So there would be, oh, and there is one other diagram. Let's see, where is it? He did draw it, and I'm not gonna. Oh, yes, I have it. Oh my gosh, I can't believe it. I have it. Okay. So here is once again, this is the cubic wave field. Now he's drawn as he calls this the basis of the atom, but he's drawn, notice these disks, and they're each at a point along. So here's once again the gravity shaft going from the center of the cubic wave field towards the corner. This would be the amplitude of the wave where a sun would be. But you see he's drawn disks at each, at the +1 position, +2, +3, and +4. So when he says disks, now I'll go back to what I was trying to draw was that there will be disks at each position. And if I were to let's see, here we go. Trying to show what Walter was what he drew in here. I'm going to attempt to kind of draw that, but essentially there would be Let's go for green. Oh, oops. Essentially, there would be like a green spiral. Let's see. I guess I'll just draw it like this. There would be one there, and there would be another one, uh, like a cone meeting at and these two cones. I don't know if you can see that. I'm sorry, but essentially, where the two cones meet, there will be a system there. There will be a circular system, and so
Mhm.
that is where our solar system would be. So when he talks about our solar system is at the position of iron, which iron is actually between the third and fourth um, locked potential position. So somewhere between 3 and 4, so our solar system, let's use blue for our solar system, would be somewhere up here spinning around the 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 yellow gravity shaft.
Mhm.
And I hope that makes sense. I know that's very
Mhm.
um does that answer your question? Or what do you think about that? Tell me what you got from that. I'm-
Yeah, I can see these progressions of the wave heading up to the amplitude, and they express different systems, and
yes.
that's cool to see where our solar system may be in terms of that wave progression. And then if you could add on another day the
Yeah.
table of the elements for
Uh,
this.
yes. Yes, that's perfect. That is a perfect thing to add into this. Hold on one second. I do have that.
So like Scott mentioned in that thread,
Yeah.
Scott Watson, like where Earth would be. I guess all the planets maybe have a preponderance of a certain element that they are
Right.
expressing.
Okay. Yeah, this is oh, can I draw on this? I guess I So here's our table of the elements. Let's try this little pen. So since this is our table of the elements, we can find iron. Let's see, iron is in the seventh octave, and it would be
So is he saying that our solar system is kind of between boron and carbon now
yes,
in yeah,
exactly. So it would be right around in here. I guess. Oh yeah, there we
yeah.
go. That would
So
be
between three
where
and four.
between 3 and 4, right? Because boron is 3 and carbon is 4. And
Hmm.
so where I've put this little blue mark, that's where our solar system would be, you know,
Yeah.
spinning around its gravity shaft,
Mm.
as it's headed
So
towards amplitude.
mm. And in terms of on that disk where our solar system is appearing,
Yeah.
there's kind of like a whole other periodic table of elements happening within that as well. Like the center of it is maybe more boron-ish, and it's,
So
you
I
know,
will,
our planets be sort of corresponding to some different elements also in a
yeah,
way.
yeah. He talks about this where, he talks about how our solar system is like kind of in the position of an atom of or right of like iron or manganese and he said something about like a giant hand. If there was a big giant who could like scoop up a bunch of our solar systems, then he would see it as iron. um but he's like, I hope you realize though that you know if you look at our solar system, there's clearly not just only iron atoms.
Mm,
Our solar system is made up of many different elements. And so he's
mm,
actually saying that even the elements themselves have all of the other elements within them. It's like
yeah,
everything is everything. And
yeah.
so
I was
everything
just
comes
wondering.
together to form systems and form systems of systems and systems of systems of systems so that it gets organized into forms, whether it's a person or a planet or a solar system, all of the solar system is made up of many smaller systems within, the solar system.
Mm,
That's I guess, the way he explains it. Yeah, even the systems themselves, even though they're made up of smaller systems, the systems themselves have characteristics like, its potential, where it is along its wave axis. Is it at position
mm,
one, or is it at position two, or position three or four? Or is it
mhm,
traveling in between? Because, like, all of this is in motion. And, the system that's at one, that's this green one here, theoretically is eventually going to become this blue system at position number two. Well, I guess in this case,
mm,
these are the positives. So it would be going up here, then coming back down here. Actually, I don't want to say that because that's a whole nother
mm,
video. But just to kind of generally to answer your question about kind of like where our solar system is in terms of his concept, is that yes, our solar system is spinning around this yellow shaft of this wave, and it's just one of these disks that's spinning around the gravity shaft of its wave. We
mhm.
don't, and he's saying that ours is kind of up here in between the third and the fourth lock potential position. So somewhere kind of at
Yeah.
the almost at the tip of the cone. And
Mm,
eventually we will evolve till we get to the number four and be a perfect, then our sun would be a perfect
mhm.
sphere, right?
So
So
these
yeah,
locking potentials must be kind of special in a way in that they express these clearly defined elements. And so the space in between them, it's kind of in like each locking position could be a breath. And so in between them is during the
like
inhale or exhale.
yeah, yes, yeah, I think so. Yeah, because everything goes in the cycle, and even the growth, from one to two and two to three, three to four. Yeah, because like
Mm,
at the lock potential position, that's like where matter, like he said, that's where we find our elements. That's just where matter has the characteristics that we see as an element. But there's matter in between
mm,
there. It's like traveling through there. But as it goes, yeah, like you said, that's like I guess the out breath. I guess the disc would be the in breath, and then in between there would be the out breath. Because this is where the matter comes together so we can see it. But then
mhm,
it has to expand, radiate, and then halfway between this disc and this disc, at some point it
yeah,
would then again like start gravitating to form again. That's
yeah. Mhm,
but yeah. So yes, that's excellent. So you're getting it. A lot of this stuff is his stuff is so universal. It just kind of applies to so many different situations once you kind of know
mhm,
what his concept is. And
yeah.
so does that kind of give you a
And it's
little
so
more clarity in terms of like how our solar system, how he's talking about our solar system and where it is in his scheme of things?
yeah, it does. Thank you very much.
All right,
Yeah.
awesome. Well, okay. Then I think I'm gonna in the session, but this was a
Curious.
definitely a great another good session. And as we get deeper, I'm really thank you, Kirsty, for your diligence of like your studying, and you're very inquisitive, so it really helps because you're kind of helping the discussion a lot by these great
Hmm.
questions you have, because you have, because your questions are the questions of someone who is actually reading the books, and I can tell
Hmm.
I can very much tell that, compared to many other questions that I get. And so
Hmm.
it's really it really helps the discussion, I think, because like
Mm.
yeah, like getting to this point, I probably wouldn't even have like gone this way, but like this is what we needed to do, in order to kind of explain it. And and as we go further along, it's like it kind of all comes together. I mean, we're all students. The president of the University of Science and Philosophy, he likes to say there are no experts, in Walter Russell, which I take a
Hmm.
little bit of offense to because I'm like, man, I've been studying this for so long. If anyone's an expert, I am like,
Yep.
but in his defense though, yeah, even I'm still learning this stuff. So it's
It's very deep.
it gets very deep. I mean, like the questions, like I said to my like the questions that I have for my mentor, it's like I have to set up the question. Like it takes me like 15 minutes
Mhm.
to ask the question, and then he's like
Yeah.
takes him 30 minutes to answer it. And at the end, he's like, man, you know, even to ask that
Hmm.
question, like you had to be really far down your journey of studying this stuff.
Hmm.
Um,
Yeah.
but but yeah, so I think it's worthwhile. And what I was saying to Scott right before you jumped on, or I'm not sure if you were on or it was right before, but which I never finished, but I was just saying like first we have to learn all this stuff. Walter's given us all of this stuff in the books and great diagrams, books, everything. We have to learn it.
Yeah.
Once we learn this knowledge, then we can start to use it. But we have to know it first. And I mean that,
Hmm.
when Scott was like, how did he, calculate, that our solar system is in, between, 3 and 4, or is at the position of iron or whatever in the fifth octave. Well, that's because he
Mm.
knows all of, and he's using his concept so I think we can all get there eventually, but we just have to
Mm.
um just acquire the knowledge that he's given us first, and then I think that's where it's going to get really fun because that's
Yeah.
where it's like that's where our own creativity will then, you know, people's different creativities can kind of shine. And I just know
Hmm.
like we're at the infancy stage of science. When I see Walter's stuff, I mean, I
Mm.
really feel like the stuff we're going to be able to do is like pretty mind blowing. So
Yeah. Yeah.
yeah.
Totally. And we have to understand the simplicity first and then try to build from that. But even the simplicity gets so complex so quickly. It's so hard
Yeah,
to keep it simple.
that's right. That's right. I mean, he does talk about how it's simple. If you can understand the simple cause of things, then you can understand the many
Mm.
complexities of the effects of the simple causes
Yeah.
and be able to trace.
And I guess it gets so confusing because the cause gets all tangled up with the effect. Like the beginning and the end are the same, and
Yeah.
like the zero and the four plus, they kind of become the
Yes.
same thing depending on what perspective you're looking at.
Yes. There is a chapter. Have you read Atomic Suicide, or do you have Atomic Suicide yet? The
No, I
book?
don't have that book.
Okay, so I
No, I
would
haven't got a
I,
copy yet.
I definitely recommend it. But yeah, there's what you just said, he diagrams that in 3 dimensions in
Mm.
Atomic Suicide. And I mean, it just about made my brain explode. Like, just think, I mean, like, oh man, it's so to conceive of like that. Yes, that like it starts somewhere and then it like ends at another place, but then at that ending is really another beginning, and the beginning of that one goes back to the start of the first beginning. It's like an infinite
Mm-hmm.
loop.
Yeah.
So yeah.
Mm-hmm.
Um yes, but I guess I'm very curious about it. I love it, and I hope to eventually one day be able to share it with people and use, and hopefully the human race can start using some of this advanced knowledge for making some advanced technologies, you know?
Hmm. It's very exciting. And even just being better humans, understanding what we are, where we are, why
Y-
we are, all of
Yeah.
that.
Yeah, exactly. Yeah, it's because it's a universal concept.
Mm,
Yeah, there's so
applies to
much that it
everything.
can, right. It can even tell us more about ourselves, Well,
Thank you so much for setting up the school. It's great. It's really exciting to be able to speak to humans about it.
yeah, yeah. Thank you. Yes, I agree. And just that Scott, he kind of said the same thing. It's before you were on, or he said it's great to be around, like-minded people or other people who are studying this, so you can talk about it. Because
Mm,
this is
yeah.
definitely not for everybody. Not everyone is interested in this.
No, no. It's so weird to feel this strange obsession with it, even though it's so challenging and ulti it's like I know it's good, but I don't know what it is, or
Right.
you know,
Yeah. Yeah.
but
But
it's
at
an obsession. It's something inside.
the rate you're going, you're gonna know pretty soon. I mean, like it's
Okay.
yeah, I think you're on your way. I'll just say that.
Mhm.
Okay, let me see here. I'm gonna stop the recording. Where is that?
Yeah,
Um,
you should get a good rest now. Had a big day.
oh yes. Let's see. So we'll
Mm.
stop
Thank you
that.
very much.
You're welcome. It's always a pleasure talking with you guys, so thank you. And you're very welcome. So I will see you guys. Well, so next week the Zoom meeting will be at 1 p.m. my time, which would be pretty early for you, I think.
Bye.
But at least for
I
right
get up.
now, I'm alternating. So in 2 weeks, then we would be at this time again. So
Yeah, cool.
all right. All
Might see you
right.
next
Well,
time.
I'll see you next time. All
Thank you
right.
very much.
All right.
Okay,
Bye.
bye.